So, thank you very much. It's great to be here presenting to you our experience of delivering Passive House schools in the UK. And I'm really focusing on how we've changed the culture of delivering projects in order to achieve the delivery of Passive House. So Archetype works throughout the UK from offices in Edinburgh, Scotland, Hereford, west of England and London. We've specialised in sustainable design for over 30 years, particularly Passive House, natural materials and low embodied carbon. We work across a whole range of sectors: education, housing, workplaces, cultural buildings. We've designed and delivered and have many Passive House projects constructed in design across the UK. This is a list of our education buildings. So we delivered the very first Passive House schools in the UK more than 10 years ago, and we've delivered, as you can see, many projects since then. We really began our journey into Passive House because we were horrified by the gap in performance between designed buildings and buildings in use. And so just to give you an idea of how big that gap can be, this is the predicted energy, electricity and gas consumption on a secondary school, traditionally designed. And this is the actual energy. So 4.7 times as much energy, 23.3 times as much gas. Really terrible difference. By contrast, this is one of our Passive House projects. That's the predicted energy, and that's the actual energy. So there's no gap in performance. And we started doing Passive House because we saw it had the potential to eliminate the gap in performance and ensure that buildings use the amount of energy that they are designed to. There's also a gap in performance in the UK, and I suspect also in Spain, between the designed comfort and the actual comfort experienced by users in the building. What you can see on the screen here is the measured CO2 levels in a classroom before we started doing Passive House. And you can see that CO2 levels are going up to 4,500 parts per million during the school day, when they really should be around about 1,000. So that's really bad air quality in a traditionally designed, naturally ventilated school. By contrast, you can see one of our Passive House schools brings the CO2 level inside the classrooms right down to the levels where they really should be, down at this level here. So we're confident from our experience that Passive House eliminates this gap in performance. So what is Passive House? Well, I'm sure many of you already know what it is, but just very briefly, it's a rigorous comfort standard. It guarantees comfortable, even temperatures, a constant supply of fresh air, and limiting overheating to 10% over 25 degrees. It's a rigorous energy standard. It sets a very, very ambitious thermal energy limit of 15 kilowatt hours per meter per year, primary energy limit of 135. And you have to prove all this using the PHPP, the Passive House Planning Package. And thirdly, and really importantly, it's a quality assurance standard. It checks, first of all, the design complies with the standard using the PHPP, and it requires evidence that the construction then complies with that design standard, including a very rigorous air test, commissioning data, and evidence that the right components and materials have been built with. The benefits of Passive House is that it guarantees that buildings perform as designed. It reduces energy by design rather than just offsetting carbon by add-on renewables. And because of all of that, it minimizes maintenance and running costs with simpler systems and controls, and offers a much more robust way to meet carbon policy reduction targets. But the challenges to achieving all that are really that in our industry in the UK, in our profession, there's a culture of complacency. People accept the gap in performance. There's all sorts of myths and misconceptions about what Passive House is. Clients need to be convinced. We have to get procurement right. We have to be able to deliver it at an affordable cost. And there's a lack of knowledge of building physics and a real need to upskill design teams and contractors. One of the biggest problems, I think, is that architects like complexity, and this undermines the drive to Passive House. Also, engineers like complexity, and really, if we're going to achieve Passive House, we need to change that culture of engineers and architects liking complexity and focus on simplifying things to deliver better buildings. So That all sounds great, but can it be afforded? We found some potential extra costs. You've got more insulation, high performance windows. You've got to achieve higher standards of air tightness, and you have to have an MVHR mechanical ventilation system with heat recovery. There are some reduced costs. You've got smaller heating systems, simplified controls, encourages a more rationalized building form, and it reduces reliance on more expensive renewables. And there are some nil costs. If we design thermal bridge-free construction, constructing less complex details, it doesn't really affect the cost at all. So I have my own rule of cost estimating, which if you start off designing a passive house building, you think it's going to cost more, 5% or 10% more, then it will, because everyone adjusts that budget and spends it on something. Maybe not passive house, maybe nice features, nice cladding. So our approach has been price is a matter of priority. Work to the budget, and if passive house is required, you make sure that you deliver it for that budget, which means you have to accept changes and compromises elsewhere. It's just a priority, a matter of priority. So you really need to achieve all these benefits of passive house at an affordable cost. You need to change the culture and rethink the design process, which means working in a circular way. Form and orientation, facade design, fabric construction, mechanical engineering services all feed into each other. You can't design the building, then the facade, then the fabric, then the services. You need to work all together as one entity. And that really means things you have to do is respond to the orientation and optimize the building in relation to solar gain and shading. You need to optimize the form, minimize the ratio between the external surface area and the useful internal floor area. You need to, and this is an example of a very simplified section to a school, which delivers that rational simplicity of form without compromising the quality of the architecture. You need to work really hard to rationalize the glazing, to optimize daylighting and ventilation whilst minimizing the extra cost that comes with triple glazed high performance windows. And you need to work hard to simplify the detailing. If you've got complicated details, at design stage, the contractor won't be able to make them airtight, and it's very difficult to make them thermal bridge free. So we really focus on simplifying every detail. And then really importantly, you need to simplify services and controls. And just an example you can see here, that's the boilers that are typical in a normal big secondary school in the UK. And there's the boilers in one of our passive house secondary schools of a similar size. One of those is a backup. You only need one boiler to power the building. And most people in the UK have a boiler that size to do their house. This is a 10,500 square metre school building. And then that's the size of the radiator we need in a classroom. So really working hard to simplify services and controls. So over the years, by following that approach, we've delivered numerous buildings within standard schools budgets. By changing the culture of how we approach design, we're delivering passive house schools for the same price as non-passive house schools. Here's an example of the very first one, built 10 years ago inside the classroom. The same client came back to us 2 years after that first building and said, our budgets have reduced, but we want another passive house school. Can you do it for less money? And we delivered the next school for a lower budget, but still to passive house and still to a good design quality. And this is a building that we did for a university, the University of East Anglia, and that came in at the median cost of all the new buildings they'd built in the last 10 years. So not the cheapest, not the most expensive, right in the middle of the costs. And our most recently finished passive house school was the very first secondary school to passive house in the UK, built in London. So you can see it's a large building, huge attention to achieving passive house, getting good internal comfort, solar shading, as you can see on the right hand side of the picture here to the south, and vertical fin shading for the east and west facing glazing. Really good quality of internal space and daylighting. This, as you can see, is a CLT, cross-laminated timber construction. So lots of really beautiful exposed low embodied carbon timber construction finishes, as well as passive house. And then this is our most recently designed secondary school to passive house, not yet built, just waiting to start on site, we hope very shortly. It's a very, very urban school, which you can see on a very tight, tricky site, right in the middle of London, near to Tower Bridge. Quite a complicated site to fit a school onto it. The road that it's next to is one of the noisiest, most polluted roads in London, and passive house became the means to ensuring good internal air quality and good acoustic quality for the classrooms. So a really sort of added benefit of passive house there. And we're currently delivering the very first passive house schools in Scotland. This is a big secondary school for the City of Edinburgh Council. Huge attention there on developing, changing the culture of the industry in Scotland, which is not yet embraced passive house, in order to meet the Scottish Government's very ambitious climate targets, which are amongst the most ambitious in Europe. So we're actually enabling Edinburgh City Council, through the design of this school to passive house, to start on their journey to meet their ambitious target of achieving zero carbon by 2030. So this project will play a really important role in that journey. So in order to change the culture, the approach that we've taken at Archetype is that passive house is completely embedded in our culture. We have a constant attention on simplifying design and detailing. We have a relentless focus on engineering value to achieve cost, and we use PHPP as a design tool from day one. I think the most important thing in achieving passive house is that you start from the beginning and build it into and use it to guide every design decision you make. If you start designing in a traditional way and then change it to passive house later, it'll always cost more. So as part of that, we test and model at every stage as an integrated part of an iterative design process. We have staff trained in building physics and skilled in building modelling, and many of our staff are qualified as certified European passive house designers. And a few staff have joint mechanical, electrical and architectural degrees and experience, so we can really work hard with our M&E engineers to integrate the design of building with services and systems. So this little cartoon really sums up what I'm talking about and the way in which I feel that passive house enables us to change the culture and deliver really good quality low energy buildings for schools. In the past, buildings used to be simple, they were very energy consuming, uncomfortable and unsustainable. In the present time, our whole industry has become fixated on complex solutions, on carbon offsetting, just adding renewables to offset carbon that buildings really shouldn't be emitting in the first place. And with the performance gap, often ending up with buildings that are uncomfortable and unsustainable. By contrast, passive house offers a much simpler way of doing buildings that drives simplicity of design, simplicity of systems, optimizing form and simplifying detailing, a really much simpler, more rational way of designing buildings that brings absolutely guaranteed energy savings, really good internal comfort, and ultimately very, very sustainable buildings. And for me, the proof really is in the experience of users and the experience of people when they visit our passive house school buildings. People are so used to school buildings being comfortable, classrooms being stuffy and hot or sweaty or cold in winter, and buildings using huge amounts of energy. Our passive house schools, the experience is fresh air, comfortable temperatures, and really low energy. The City of Edinburgh Council, if their 10 most recently new built schools had all been passive house, they would have saved something like €1 million a year in energy running costs for those school buildings, and more than 20 million over 20 years. So Passive House really does offer energy saving, comfortable and sustainable school buildings. And perhaps one of the most important things is that the teachers report that the children can concentrate better in Passive House classrooms because of the improved air quality. So thank you very much. Hope you found that useful and interesting, and I'll obviously be very happy to answer any questions in due course. Many thanks.